Hello friends, my name is Pasan. So let's start with the chapter 1 from the book Most Adequate Guide to Functional Programming and written by Professor Franklin Frisbee. So it's also called Professor William. So the introduction. So in the introduction part, he just mentioned that what we need in order to start this book, what the basic like he mentioned that you need not to be a PhD on the object oriented and JavaScript. You just need to know the basic concept of JavaScript and the bit of knowledge of object oriented how it's work. That's it. Apart from the expectation, he mentioned that uh, he expects from us that we don't have any it don't expect like we already know the some of the concept of functional programming. So basically, he just thinking like we don't know anything about it and the how the mutated state are mutate and all the side effect and all the principle related to the functional programming. So that is going to be teach us or mention all the uh, concept here in the upcoming chapters. So let's and this he mentioned here the journal programming principle like we already know like we keep us code like do not repeat ourselves or we the function should be based on the high cohesion and the loosely coupled and the principle of least surprises and single responsibility all as you're aware of the solid principle this is all about it and here let's start with a brief encounter he just give example given a simple example of the SQL application. So the basic application it's say when the flocks can join, they become a larger flock, and when they breed, they increase by the number of seagull with whom they breeding. So this is the basic concept. Now it's written this concept in the way the classes, and here he just write and he get the output 32. So there is a one issue in the code right now. Here we are using the same variable and passing and all the way using the same variable and mutating the state of this variable. So there is a issue in this code. That's why we are not get the desired output. It should be 16, but we got 32. So this is how we writing and the things and we are. I mean, if you see how the code is written, so it's very difficult to understand and how the flow is going. It's very better confusing confusion over there as well. So so he here he mentioned he tried with a different approach. Here it's called functional approach, and here we get the same desired output 16 because we are not going to mutate anything. We are whatever we have, we just return the back the value and the value, and we are not uh, playing with the objects. We are not here as we know we are playing with this reference and we are returning back this object. But here we are using the functions concept. We are just returning the whatever value we have. So let's quickly into the terminal and see how it's look like. So I'm going to so basically I have already copied some of the code here so just to give you a basic understanding. So what I did, I just paste this class here and to see how the function is running. So this is the same class block. And so if we are going to use, if we just pass see the output, so here if you see 4, because we are passing into a constructor new value, and here we are initiating the new variable 2 as well. So this is how the output look like. So in the result, if we are saying we are calling this function, and we call this function two times, 432, and here we called the speed function again two times, we get the output is 8 and 16. So like here we call this, and here, so basically what happened when we are, if you see the flow, so we using this can join function here. So can join function, first we pass here the value, we will got the 4 output, and then we move this function to use this read, and here we get the 8 output here. And now the then there's the same, and here if you're talking about this, it has a value now, and now the value function has 8 value, but you should expect it should be a, it should not mutate, right? But this variable is not in the mutating state, and then that's why we get the inconsistent behavior here as well. So that's why it's written the output as 32, because this variable is mutating throughout the flow of this chain. So let's move here and see how we have rewritten this function in some of the functional way. And right now if you see here, we are not going to mutate any state, and we are getting the desired result 16. We can use this function in the better way. So before going ahead, let's quickly learn some of the laws, mathematical laws. So first we have a commutative law. It say that if you are going to swap two numbers or two variables among themselves, we will get the same result in case of add and multiplication. If we are doing the multiply with the same number, and we get the same output. And if you see in the percentage as well, it will get the same as example 8% of 50, which is 4. Why? Because the number can travel back and forth. So it's mentioned that why it's called a cumulative, because the number can travel back and forth like a commutator. So that's why it's called a commutative law. So associative law, it's basically uh, related to the parentheses, the way we are group the numbers together, we will still get the same result without modify the position of the variable itself, without applying this law. It's basically commutative law, so without rearranging this variable. So if you see ABC, and so still ABC, but we are group first two numbers, then last two numbers, and still we get the same output, still in the case of multiplication as well. So this is say the associative law. And the distributive law is the best of all, because one of all needs. So here what we are saying, like, as we are already aware of this, so to multiply the two number, we need two units like x and y in order to do that. So right now we have x, but we don't have actual solid value to multiply. So what we need to do, we need to first solve the parentheses and then multiply with the number, so that we will get the desired output. But We can do the other way as well. We can first multiply with inside the parentheses like 3 multiplied by 2, and then 3 multiply and then add those value. We will get the same result as well. So this is called a distributive law. So we can rewrite this method like this, and we still get the desired behavior, which is 18. So these all are the three laws we talked about, and let's quickly move into the chapter. Whatever are we doing? So yep. So what he did here, he just rewrite all the code here, and then get the desired output 16. Uh, so if you see here, so if you see, these all are the can join and read a simple addition and multiplication. So what I did is just rename these all the function and rewrite again, and to bit clear understanding. So all the code I have copied to my VS Code. Let's quickly go through it and see how it's look like. So let me comment. Okay, these are the function can join and can read. So we are using this function, and so if you see like here, this function breed called two times, and can join calls also called two times. When you called breed first time, this we got the result 8 from a multiplied by b. A multiplied by b, we get the 8 result, and here right now the value is unknown, so we know the value of flock beats 2, but we don't know the value of a and c. So here we call this method can join, and we will get the desired output, which is 4, and then we call this method, we get the 8. And can join, as we know, is simple addition, so we are going to add those two numbers 8 and 8, we got the result 16. So but and here in this example, so let's quickly move into the next example where he rewrite this function into a simpler way. I mean, the use called rename the function name to add and multiply, and still got the same result, reaching which is 16. Okay, so let me show you as well. So this is the 16 as well. So there is a here is the original code. We can rewrite this code something else by using all the all the laws that we have learned. So let's quickly uncomment this code and show you about these laws, and later we will come back to this book. So if you saw, like, this is associative law, we have already, without changing the position of the variable, but we just update this parentheses and the method, so we'll get the desired result 6. And here combinated with change the rechanging the variable position, we get the result. And for the distributive law, what we did, we just multiply, like for example multiply this, multiply x at this, we got the 8. But what we did, we just used the multiply two times and then add the number again, we get the same result. So this is how it's look like. So let's quickly move to the book. So this is, he mentioned that this is our original line, and then we are using this identity method. So here is the identity law. So identity law is basically the value that we are any value we will apply to any method, apply to any variable, that will give back the same value back. For example, and that value is called the identity. to that method. For example, if you're talking about the addition, we have 0 as an identity. If you multiplied 0 with any value, sorry, add any value with 0, we get the same outputs. And the multiplication, we have a 1. So if we multiply with any number with 1, we get the same result. 5 multiplied by 1, we get 5. 6 multiplied by 1, we get 6. And same 5 multiplied 5 plus 0, 5. And 6 plus 0, 6. So here we use identity. So we just rewrite here. So rather than writing this function here, because we know this is a 0, clocks clock is zeros, and when we, rather than writing this function again, we just use the clock a here, and then we just shorten this method a little bit. And here this is the original line, and this is the actual line. We just shorten a bit, and then we are using the distributed property here, and we will short this method again, and we get the desired result here. So this is all the laws, and this is how it was earlier. This is the old one, and then the 16. Then we will rewrite this like this, and then finally like this. So I just print out all the laws, the associative law and the commutative identity and the distributed. We get the same result. I think this is all about today. This second chapter, so first chapter of this book, most adequate guide to functional programming. So right now I don't think so we need to go into the whatever he mentioned here. He just just give us talking about all the things like don't disappear. So this is a talk about the book as well, and the mathematical knowledge related to the to understand the concept. So I think this is all about the chapter first. So thank you very much. So I hope you like this, and we will go through this first class function to our next class. Thank you, and have a good day. Bye.